All right, let's get right into it. We're all connected, all the time, right? But have you ever actually stopped to think about the invisible world that makes all that possible? Today, we're going to take a journey deep inside the secret life of your data, starting with the brain of the 4G network and riding all the way to the 5G superhighway.
You know, it feels like magic. You tap an app, and bam, the world is at your fingertips. But in that tiny split second, there's this incredibly complex, beautifully choreographed dance happening inside the network's core. And today, we're going to pull back that curtain.
So, to really get a grip on where we're headed with 5G, we first have to look back at how we got here. And let me tell you, the jump to 4G was a massive, massive leap.
I mean, just look at this progression. It's kind of wild. We started with 2G, which was really just for voice calls. Then 2.5G gave us our first little taste of the mobile internet. 3G was a big step up, combining voice and data. But 4G LTE, wow, that was the revolution. That was the moment we truly got the internet in our pockets. And that required a brand new, incredibly powerful brain to handle the data explosion.
And that brings us right to the star of the show, the network's brain. In the 4G world, we call this the Evolved Packet Core, or just EPC.
So the EPC is basically the command center for, well, everything. Every single bit of data, every video you stream, every message you send, it all flows through this core. It's the unsung hero that knows who you are, where you are, and connects you to the rest of the world.
You know, to really make sense of this, let's use an analogy. I want you to think of the EPC as a huge, bustling, international airport, but for your data packets. Every part of the EPC has a super specific job, just like all the different departments you'd find at an airport.
Okay, first up, we've got the MME, which stands for Mobility Management Entity. This is the airport's air traffic control tower. It's the very first point of contact for your phone. It's constantly aware of which cell tower you're connected to. It handles you logging on, that's your plane taking off, and it tracks you as you move around, ensuring your connection is seamless.
Then there's the HSS, the Home Subscriber Server. This is like the airport's master passenger database. It's got your passport info, so to speak. It checks your ticket, confirms you're a legit subscriber, knows what data plan you're on, and basically gives you the green light to access the network.
Next up, the Serving Gateway, or SGW. Think of this piece as the local tarmac at the airport. It's responsible for routing all the data packets, the luggage, the passengers, the whole deal, to and from the specific cell tower or gate that you're currently using. It's all about managing that local traffic flow.
And finally, we have the PGW, the Packet Data Network Gateway. This one's the big one. This is the international gateway for our entire airport. The PGW is the single point of entry and exit that connects the mobile network to the public internet. It gives your phone its IP address and sends your data off on its journey around the world.
So, this 4G airport system was absolutely brilliant. For a decade, it powered the entire mobile revolution. But the world kept changing. We started demanding things that 4G was just never built to handle.
And this demand wasn't just for, faster cat videos on our phones. It was for a totally new kind of connectivity, for a future where literally everything is connected.
And here are the new challenges, right? Suddenly, we're talking about cars talking to each other, about billions of tiny IoT sensors in our cities and on our farms, about intelligent traffic systems. Our good old 4G airport, as reliable as it was, just wasn't designed for this massive, incredibly diverse new kind of traffic.
But here's the thing, you can't just shut down a global network overnight and build a new one. The transition had to be smarter. It needed a bridge, a way to get us from the 4G world to the promise of 5G. So, this lays out the two main strategies. On one side, you have the upgrade path. It's the pragmatic choice. Take the existing 4G EPC we know and love and just evolve it to handle 5G radios. This gets 5G speeds out to people fast. On the other side, you have the revolution, a brand new 5G core built from the ground up for the future. As you can imagine, most operators started with the upgrade.
So let's break down how this bridge actually works. This approach is often called non-standalone 5G, and it's pretty ingenious. Your phone keeps its main essential control connection on the rock-solid widespread 4G network. But then, when you need that extra speed, the network opens up a parallel 5G data connection. Think of it like a super fast carpool lane opening up on the highway. And the network is smart enough to split your data between the two for the best possible performance.
Okay, so that bridge got us 5G speeds, which is great.
But to really unlock the true potential of 5G, we're talking smart cities, connected cars, all that cool stuff. We have to complete the journey. We need to get to that revolutionary 5G core, which thinks about connectivity in a fundamentally different way.
And this comparison table really tells the story. The 5G core isn't just an update, it's a total redesign. It moves away from that rigid box-by-box structure of the 4G EPC to a super flexible, software-driven, service-based architecture. This is what allows for incredible things like network slicing, where you can create dedicated virtual networks for specific jobs. One for self-driving cars, one for tiny IoT sensors, and one for your phone, all running on the same physical gear.
And that pretty much brings us to the end of our journey today. We've gone from the brain of 4G all the way to the 5G superhighway. And look, this was never just about faster downloads. It's about building an entirely new foundation for innovation. So the real question isn't just what is 5G, it's what will we build with it? When literally every device is connected, what will we create next?